Okay, hello there, and welcome to part one of looking at key stage 4 energy. Now, if you're just coming into this is the continuation of the series of the key stage 3 look at energy. There will be references back to that key stage 3 sets of lessons, set of 6 lessons. So if you are just starting from scratch, you may want to go back and have a look at the key stage 3 things first. If not, we'll carry on from here. So Key Stage 4 is going to be a series of 9 small lessons. What we're looking at first here is going to be a continuation of the energy types. Now, as I said, at Key Stage 3 we had a look at the energy types that are involved there, the 6 main ones here. Now at Key Stage 4 we actually have 10 different types. Now obviously 10 different types of energy, there's lots of things to try and remember. Now the best way that I've tried to find it was actually, if you have a look for this, it's actually on the BBC Bite-Size Key Stage 4 way of remembering it, and this is called Most Kids Hate Learning GCSE Energy Names. Now the reason why that is up there is because that's all 10 different types of energy that we're trying to remember. Seriously, it took me so long just to remember what this second E is. It really is worth trying to get this stuck into your head. So again, it's Most Kids Hate Learning GCSE Energy Names. So we said our M for most is magnetic, kids K, which is kinetic, H for hate, which is heat, L for learning, which is light, and then our GCSE, which is our gravity, our chemical, our sound, our electrical, and energy for elastic potential, and N names for nuclear. So what we're going to do is we're going to have a look at all these different 10 types of energy. We'll go through them one by one. As I said, some of these were at Key Stage 3, some of these are new for Key Stage 4. So we'll have a look. So we're starting off with one of the new ones, which isn't mentioned at Key Stage 3, and this is magnetic, or magnetism. Now, magnetism, it can be either, as its name suggests, it can be as part of a magnet, which we have here, it can be part of an electromagnet, which you will learn in your electronics part of your science. I'm actually going to make some other lectures about electricity and electromagnetism, but that's, as I said, another set of lessons. Also, magnet is obviously inside our Earth. Now, this is where we get our North and South Pole from. So the actual force from the magnet actually flows around the magnet, but also actually flows directly through it as well. Now the magnet is said, the same as our Earth, we have a North Pole and a South Pole. A magnet has a North Pole and a South Pole as well. And the magnetic lines, which is called the magnetic field, which is the distance to which this force is actually carried around, always travels in the direction from north to south. So it will travel directly through the magnet, or it will also travel around the magnet, going from north to south as well. So next up, we are having a look at kinetic energy. Now, as I said, this one was mentioned at Key Stage 3. Generally, kinetic energy is described as a transfer of energy from potential energy into movement. So kinetic energy is all about movement, which is why obviously we've got our cheetah absolutely flying away here, and our family coming down the mountain on skis. So it's the idea that anything has potential energy. So, for example here, I've got a bit of a window handle for some reason. This is holding here, this has potential energy. Well, technically it has gravitational potential energy, but we'll get to gravity. But potential energy, so this has the potential to do work. So kinetic energy is where that potential energy that it has is transferred into movement. So as soon as I let go, it will move, and that movement is kinetic energy. Okay? So next is heat. Again, this was at Key Stage 3, it's otherwise known as thermal energy. Now generally, heat energy is a product from another process. So for example, fire, here, which obviously gives off massive amounts of thermal energy, also gives off light energy, but we'll get to that, gives off heat energy. So this is actually from the process of something being burnt, so it would actually come from another source. So exactly, it could be from a chemical source. So you know, when you have your Bunsen burners in school, and you know the gas itself is on fire, so it's giving off thermal energy. So it's having a small part of energy put into a system, which will then actually release heat or thermal energy out. As I said, heat is generally a product of another process. So it's called heat, also more accurately called thermal energy. Next up, light. Again, another one that we saw at key stage 3. Otherwise known, that another name that's not actually comes out at key stage 3, it's called radiant energy. Now, light itself can obviously naturally occur, which is how we get the source of energy that we get from the sun, but it's also, we can produce it ourselves via electricity and through light bulbs. Now, as you should remember from key stage 3, light energy is one of those things that is quite special in terms of the fact that it's carried on something called infrared radiation. And unlike most of the other types of energy that we do have, it doesn't rely on interaction with molecules or with a gas, so it's one of the very few things that can occur in space. So it doesn't need air for it to actually work. So that's how we obviously get our light from the sun. So next we are looking at gravity. Now again, we did look at gravity at key stage 3. Those of you who've watched the key stage 3 lectures will recognise this stone on the rock that we used before. Now gravity is also more accurately called gravitational potential energy. So if we go back to my window handle that I've got on the floor here, as we were saying, we're talking about gravitational potential energy. Now potential energy is on any object that is stationary. It has the potential to do work, or it has potential energy within itself. When it becomes gravitational potential energy is when it is above ground level. So this window handle that we randomly have around has gravitational potential energy, and at the moment it's stationary. And as we were talking about earlier about kinetic energy, when I let go of it, gravity takes a hold of it, pulls it down to the ground, and that potential energy becomes kinetic energy. So potential, or in this case gravitational potential energy, is only in a stationary object. As soon as that object starts moving, it becomes kinetic. So we have potential, kinetic, and as it hits the ground and it's stationary again, it then has potential energy again. Okay, so we move on from gravity, and we have one again which is briefly mentioned at key stage 3, but obviously we'll go into a little bit more detail now. This is chemical energy. Now, this is generally can be described as a source from food, from fuels, or from batteries. So, an example here, the picture that we've got here is obviously somebody, I don't know whether it's a man or woman, you can't really see. I'd say it's probably a man. He hasn't got any nail varnish on or anything. He's in need of a manicure. But anyway, we've got a match here. It's obviously producing its thermal energy at the moment because it's on fire. So what's actually happened is that on the end of a match you've got your red dot that's actually made up of a few chemicals. Now, with the introduction of some kinetic energy and obviously some friction, when you strike the match, there's energy put into those chemicals, and those chemicals then transfer that energy, in this case, into thermal energy, into light energy. Now, the actual chemical energy itself doesn't just come from that little dot, or that little red piece on the end of the match, which is chemical energy, but it's actually from the wood itself. The wood itself has chemical potential energy stored within inside it, which can be unlocked, if you like, or used up by this thermal energy, and is actually itself used to create the thermal energy. So again, although it's just called chemical energy, again it can be described as chemical potential energy, because again, it will take an interaction between either two chemicals or some friction or any other number of ways in which you can change those chemical properties as they are from potential energy, in this case, into light energy, thermal energy. So as we move on, we're now looking at sound. Now, sound again was at key stage 3. This type of energy itself, as we described in key stage 3, is very different to, again, a lot of others. It shares some similarities with light energy in terms of the fact that it has wave properties. However, with sound energy, sound is produced from the vibration of an object. So as I'm talking, my little voice box, my little voice cords, vocal cords in my neck are vibrating, which is causing the sound. As I'm talking, that sound is then coming out and is vibrating the molecules in the air. As it uses them, it almost sort of leapfrogs, uses them to leapfrog across the room until it then reaches your eardrum, or whoever's listening to me, or in this case I'm in an empty room and no one's listening to me. So I'm just hearing myself because it's bouncing off the walls. So what's happening is obviously that's hitting my eardrum, that's vibrating, which is then obviously working the bones and everything in your ear, which is how you hear. Okay, so as I said, that's a key stage 3, but because this relies on the vibration of molecules, sound does not work in space. Unlike light, which doesn't rely on the vibration of molecules, because it's infrared radiation, it can just travel through a vacuum, which is space. So sound relies on air, whereas light or infrared radiation doesn't. So electrical energy, this is a new one for key stage 4. Now electrical energy, this can either be electrical energy which is moving, or electrical energy that is static. Now this itself can actually be produced naturally, or actually produced by ourselves, by humans. We can, well, not ourselves, I can't just go like that and produce this type of energy. Unfortunately, I'm not a superhero, as much as I'd like to be. But obviously with power stations and so forth, which we will go into in future lessons, we can actually create electricity. So what it is actually the movement, or the static, of charged particles or charged molecules, which itself can then be turned into electricity, which is obviously electrical energy. But as I said, we will go into a lot more detail about electricity over the course of these 9 small lessons. So elastic potential, again another new one for key stage 4. Now as I said before, when I was trying to remember all of the 10 different types of energy, remember, most kids hate learning GCSE energy names. This is the energy, this is the second E, it's elastic potential. So basically this is described as the stretching or squashing of an object. That means that the amount of which you can stretch an object and it can form itself back to its normal shape, or the fact you can squash an object and it can expand itself back to its standard shape again, is described as how much elastic potential it has. So, you know, same as I had a rubber ball. If you go back to key stage 3, where we're talking about gravitational potential energy, I had that little foam ball. If you dropped a foam ball, the more elastic potential of the ball, the more it would squish as it would hit the floor, therefore the more it would bounce back up again. So anything like a rubber ball or an elastic band, you know, when you're flicking bits of paper across the room with the elastic band, it's called an elastic band for a reason. I mean, it has elastic potential. So as I say, it's up to the point at which you can stretch something so it returns back to its normal shape. That's how much elastic potential, and that's again another type of energy, because it's potential energy, because once you've stretched it, it has the potential to retract itself back again. So you're actually putting kinetic energy into it to stretch it. Once it's held there, it has potential energy. When you let go, it moves back again with that kinetic energy. Okay, so that is elastic potential energy. And don't try and put a car in a big sling like this, because 1, you'll need lots of rubber, 2, I don't think your parents will be too happy with slinging their car up or something. Okay, and the final one we're looking at is nuclear, which we did have a very, very brief look at. But nuclear, so this is obviously the Trojan power plant from The Simpsons. Now nuclear energy, again, it can happen naturally, or again, we have, as humans, have managed to harness ideas and factories of which are nuclear power plants that we can use to use this energy to again create electricity. Now nuclear is, as the name suggests, is all to do with the, harnessing the energy of the nucleus of atoms. Now there's certain materials which are called radioactive, which is to do with the nucleus. So those are the materials that are involved in nuclear power plants. That's also involved, what's involved in the sun. That's how the sun produces all of its light, all of its heat is through nuclear processes or through radioactivity. Again, we will have another look at this where we look at different energy, different ways of making electricity in terms of the energy types, because there is things, as I say, going back with solar energy, is all to do with the sun and radioactive materials and nuclear processes that happen in the sun, as well as obviously looking at geothermal types of energy, which is to do with radioactive decay in rocks at great depth. So this is all to do with nuclear energy. which is, as I said, it's all to do with the nucleus of atoms and releasing and harnessing the energy from those nucleuses. Okay, so this is basically just the end of the first lesson. So it's just an introduction to the additional energy types that we were looking, having stepped on from Key Stage 3. So yeah, all the 10 different types of energies and the basic concepts of how those new ones do work, and a little bit more energy of a little bit more example, of how the old ones we looked at Key Stage 3 work. So our next lesson is going to be looking at heat transfer and also at thermal radiation at Key Stage 4. So we've had a look at heat transfer at Key Stage 3, so it's just going to be a more in-depth look at that. And thermal radiation we had a very brief look at, but as I said, we will be going into a little bit more in-depth with that as well. So that's the end of lesson 1, so there will be 8 more in the series. Okay, thank you.